Addition and subtraction with fractions requires the same denominator in the fractions you're adding or subtracting. So let's start by looking at some problems where the fractions have the same denominator. I've written up here 2/7 plus 3/7. I'm going to rewrite each of these fractions this way. We know that dividing by 7 is the same as multiplying by 1/7, so I'm going to write this as 2 times 1/7 plus 3 times 1/7. We can do that with fractions whenever we want. Dividing by 7 and multiplying by 1/7 exactly the same thing. So now when I look at it this way, I can say to myself this: well, I have 2 of these 1/7 here, plus another 3 of these 1/7 over here. That gives me a total of 5 of these 1/7, and that comes out to be 5/7. So that's just kind of to show you why it is that 2/7 plus 3/7 comes out to be 5/7. Why we add the numerators, but we don't add the denominators. The denominator just stays the same, and as a matter of fact, has to be the same in both cases. Now, to go this step right here, if I wanted to show another step, I could show the distributive property. This is the same as 2 plus 3 times 1/7 using the distributive property, and so you can see that that would be 2 plus 3 is 5 times 1/7. Or just think of it as 2 of these things plus another 3 of the same thing. That's going to be 5 of those things. In any case, that gives us a reason to write our rule for addition and subtraction with fractions this way. A over C plus B over C is A plus B over just C. So the requirement is that the denominators in both fractions are the same, and that's the same denominator that shows up in the answer. A over C subtract B over C, same idea. The answer will be A minus B, subtract the numerators like that, and put the answer over that same denominator that you had to begin with. So it's a requirement for fractions that we have the same denominator to begin with if we want to add or subtract them. Okay, let's look at 3/8 plus 1/8. Well, according to our rule right here, this is going to be 3 plus 1. I'll add numerators, put that over that same denominator that I had to begin with. I'll simplify now, 4/8, and then I'll reduce to lowest terms by dividing out that common factor of 4, and I end up with 1/2. So adding fractions when they have the same denominator, pretty simple process. Here's one more problem that has both subtraction and addition. I'll just extend my rule here to just say, well, as long as the denominators are the same, I can just take care of the addition and subtraction in the numerator. So this will be equal to 3 subtract 2 plus 9, all divided by 5. And we know because of the rule for order of operations that we have to do addition and subtraction left to right. So 3 subtract 2 is 1, plus 9 is 10. All divided by 5, and then that will simplify down to just 2. So adding and subtracting fractions when the denominators are the same, pretty easy process. Let's take a look at what happens when the denominators are not the same. Let's start with 1/3 plus 5/6, a couple of fractions with different denominators, okay? And I say, well, okay, let's see if I can make this fraction into a fraction that has a denominator of 6. So what I'm going to do is this. I'm going to take this 1/3 and I'm going to change it a little bit. I won't do anything with the 5/6, but what can I do to this 1/3 right here where I won't change the value of it, but I'll end up with a fraction with the same value but with a denominator of 6? Well, the answer is I can multiply it by 1 in the form of 2 over 2. So this number right here is just the number 1. So I know if I multiply 1 times 1/3, I'm still going to get 1/3. But look, when I multiply 1 in the form of 2 over 2, I'm going to end up with 1 times 2 is 2 over 6 plus 5 over 6. And I think you know that, right? You know that 1/3 and 2/6 are exactly the same thing. I did this because I can't add these two fractions unless they have the same denominator. So this problem, 1/3 plus 5/6, is the same as this problem, 2/6 plus 5/6. Now I'll just add numerators and get 2 plus 5 is 7, divided by that common denominator, 6. Okay, so Again, the number 1, very important here, because I know if I multiply a number by 1, I won't change its value. I'm changing its form, but not its value. How about 1 plus 1/2? I'm going to add these two. I'm going to think of the 1 as a fraction. I know it has to have the same denominator as my other fraction, which is 2. So how about if I just write this problem as 2 over 2 plus 1 over 2? Isn't this still the number 1? Sure it is. So 2 over 2 plus 1 over 2, I'll add numerators. 2 plus 1 is 3, and put that result over my common denominator 2. So anytime you have a whole number like this, like 1, and you want to add a fraction to it, you can think of that 1 as 2 over 2, or 3 over 3, 5 over 5, 7 over 7, whatever's convenient. In this case, it's convenient to think of it as 2 over 2 because I'm adding it to 1/2. Okay, how about 5 plus 3/4? 5 plus 3/4. Well, I want to write 5 as a fraction with a denominator 4. So what number what fraction has a denominator of 4 and a value of 5? Well, if you think about it for a little bit, you'll see, well, how about if I write 5 as 20 over 4 plus 3 over 4? Isn't 5 the same as 20 divided by 4, or 20/4? Sure it is. So I have 5 plus 3/4. I'll add numerators. 20 plus 3 is 23, all divided by 4. So we're just doing this kind of intuitively. We don't have a method. The only thing that we really know is that we can't add or subtract fractions unless we have the same denominator. So that's our goal, and then we just use whatever kind of things we know intuitively to get us to that point. 1/8 plus 2. 1/8 plus, well, if I'm going to add this fraction to another fraction, that other fraction has to have a denominator of 8. But I can't change the value of the 2. It still has to have a value of 2, but also be written as a fraction with denominator 8. So what should the numerator be? 16. 16 over 8, that's the same as 2, so here's my problem, 1/8 plus 2. But now, at least I can add the 1 and the 16, get 17 over 8, and there's my result. So next what I want to do is take a couple of little more harder problems and see if we can't develop a method for finding a common denominator regardless of what the fractions look like to begin with, so we can take whatever our original problem is, change it to an equivalent problem with fractions that have the same denominator regardless of what denominators we start with. Let's go to the next board and check that out.